Yes, sir. Please proceed.
Hello. How many participants are there? I'm not able to see.
Sir, there may or may not be participants, sir. The meeting will be recorded and it will be uploaded in our site. So our members will view offline. Okay. Please start, sir.
Hello. On behalf of agriculturalinformation.com, I consider this a privilege to present to you a chapter on compressed biogas from agricultural waste. I am Divakar. I am the Vice President Marketing of Acclaim Technology Services, Chennai. We are talking about managing agricultural waste. So here we get a clean, green and renewable energy. The slides that are coming up are self-explanatory. In any case, I will also assist you so that we have things in clarity. We have, over the years, we have developed and come out from the Stone Age, Bronze Age, and now we are in the age of garbage. So post-harvest, agricultural waste is the main cause of water, air, and land pollution. We can segregate the waste into two main categories: biodegradable waste and non-biodegradable waste. So we are coming under agri waste, which is biodegradable waste, and it can be treated in two ways. One is biomethanation route, and another one is the burning. So we are today going to focus on biomethanation. Organic waste is transformed into compressed biogas. This is the scheme of things. Wet waste transported to biogas plant. Biogas plant converts the waste waste. There is a preparation going on. Biogas upgraded to CBG. We are compressing it, cleaning the gas, compressing it, because the raw gas has only about 55% of usable gas. So we are cleaning it up to come to 90 plus methane. Then CBG is provided the gas filling stations. Normally, this is compressed at 210 bar and transported to the filling stations. So, what is biogas? It's a gaseous renewable energy source produced plant and agricultural waste by anaerobic digestion, organisms of methogens in a bioreactor. So 55 to 70% is what you get methane in the normal biogas decomposition. Then carbon dioxide, H2S, and we clean up the traces. Biodegradable waste, we are talking about, there are different types of biodegradable animal waste, then mainly agricultural waste, grass and garden, trims, dry leaves, sawdust, rices, whether commercial crop or a food crop, only less than 30% is the useful product or digestible product. The rest is all wasted. This waste is a resource which we are destroying by burning or mulching, contributing to global warming. If you look at the scheme of things, when you burn it, you generate carbon dioxide. When you cut it and put it into the field, it leaches, and the gas that is coming out is methane, which is 20 times more dangerous than carbon dioxide. Waste to value concept, that is what we are talking when we are talking about harnessing this for biogas. More waste is generated post-harvest in agricultural practice than edible or usable portion. As I told you, you take all of this, sunflower, this is the major waste, cabbage after harvest, maize, rice, wheat, groundnut. You can think like this, any harvesting methods, whether it is food crop or for commercial crop, our requirement is only 30%. The balance of 60 to 70% is either mulched or burnt. So we are going to concentrate on this thing which we are wasting. We can also grow grass. We can also grow crops which can be used for compressed biogas. So here what happens is we will not have to have a conflict with commercial crop or food crop. Wastelands, they are wasted lands. This is where we are talking about growing captive plantations for making biogas. So this is the new alternate for replacing fossil fuels. So Napier grass, we have different varieties, CO2, CO3. These are also improving with each research. So it's a high yield dedicated energy crop as a low carbon renewable replacement for coal to generate electricity and heat, and as non-food feedstock for second generation liquid biofuels to replace fossil fuels such as gasoline and diesel fuel. So why we choose this? Already there are invasive species, and you must have seen Madras High Court has brought very strong strictures that this should be eliminated. They only said it should be eliminated, but after elimination, what to do? That has not been specified. That is where entrepreneurs have to come in, government has to come in, and together there should be a program where we can have this as a resource for generating biogas. So now captive growing of Napier grass has its own benefits because we have control on the yield, we have control on the raw material pricing, which is very essential for a profitable bio-CNG project. So these are also resources for bio-CNG. Water hyacinth, Juliflora that you see all around. This is what government, the court has said has to be eliminated. These are again resources. It has got a resource both as biomass and as a raw material for biogas. This is the flow chart. So your biodegradable waste will come to a collection tank from where we will be processing it and sending it into a pre-digester. Then we take it into an anaerobic digester. From there, it goes, the gas is generated. We get a gas which is stored in balloons. And then the manure comes back as a substrate where we can split it out into liquid manure and solid manure. The liquid can go back to the digester, and the solids can be used as manure. It's very rich in minerals and nutrients. And our experiment with farmers have shown that it is giving a better yield of 20 to 30%. Number one. Number two, the health of the plants are better so that you require less of fertilizers and pesticides. So this fuel that is coming out, we are cleaning it up, and then this raw gas can be directly used for heating. But when we want to store it and transport it and then use it, then we will have to go in for compression. So the compression is, because it's a lean gas, we have to compress it at more than 200 bar, which is an exercise in itself and is the most expensive component of the whole system, cleaning and compression. So it can be used for power or it can be used for fuel. So it can, a 500 kg system can always save around 1,000 LPG cylinders per year. So this is the typical savings in biogas plant, which we have arrived at numbers which we have calculated. These details I can share to people who can write to me. I will show you my address where you can contact me in the last slide. You can note it down, but just understand that if you are processing a waste of 1,000 kg per day, it will give you a return of 11,88,000 rupees per annum. These are the main components of the biogas plant. It has a bioreactor. First is the raw material processing that varies from your crop to crop or your whatever is your input. Then you have the residue tank where the substrates come in after the gas generation. These are the balloons which we store the raw gas and also the clean the gas, and then we compress it and send it into the cylinders. These individual cylinders, we use it for domestic purposes and for canteens and all who use lesser volume per day. And then we convert it into an array and transport it. The problem we will realize is that since it's a lean gas, a 10-ton truck can carry only 1 ton of this gas. So this is a major challenge and a cost component. So the applications what we can come, this is in a boiler, in a domestic sink. It's a good gas, clean gas. Cooking, chips making, drying, in tea drying, copra drying, you name it, we can do it. Then we chilling air conditioning using vapor absorption chillers. Then power. We can use it for power generators using gas generators. Now options are available. Vehicle fuel also, it was used during World Wars. Today we are using CNG kits. So this is an ideal one which we are doing from 50 kgs to around 200 kgs. This comes in an HDPE plant. It is an independent unit which is plug and play system. So this can be done with HDP. It has got a life of around 15 to 20 years. The solid 8 to 10% of input and liquid byproducts are nutrient rich and can be used as manure. As I told you earlier, this manure is very rich, is nutrient rich, and our field experiments have shown more than 30%, nearly 30% more yields and a strong immune system for the plants that it requires a continuous application over a period of time. It is reducing the input requirements of fertilizers and pesticides. This is the organic bio slurry that is coming out. Depending upon your input, around 10 to 20% of this will be available. Organic manure, wet fertilizer, dry fertilizer, composting material, aquaculture, vermiculture, seed coating, pesticides, weedicides, improve soil health. All the benefits come with this. Available in standard sizes, or we can custom engineer to larger sizes also. As I told you, we can directly, if it is a canteen or somewhere where the gas is generated from in-house itself, we can set up this plant and the gas without cleaning can directly be used in the kitchen. This is one 500 kg plant which we set up for TNPL. This is SSM Builders. This is a condominium of around 3,000 houses where a 3-ton plant has been set up and the gas is used directly in their kitchen. They have a kitchen, they have a college, and so the kitchen uses this directly. This is a CSR project by our colleagues in Kalyan, where it is a 25-ton plant, which is using MSW, biodegradable MSW. This is a continuous biogas plant which is standardized for 2-ton. So the space constraints, we can take it directly and have it. This is also a plug and play system. This is our plant which we have set up. This is a 4-ton plant, 100-ton TPD input, and the output is around 4 tons per day. The raw material used here is mucilage, that is coffee waste. The challenge here is that this coffee waste is available only during a specific period, around 3 to 4 months in a year. And then after that, what to do is a challenge. That is where we have to take into consideration when we are looking at the seasonal products like press mud and all these things, what to do with that after that. So the advantages, biodegradable waste processed at source without creating any environment, zero waste concept. Transporting and dumping eliminated because we can have small plants at different levels, or we can process them there and transport it when we will find that the transportation cost will be reduced by around 60 to 70%. The plant can be constructed underground without space wastage, environment friendly since the process does not generate any polluting liquids or gas, simple to operate, almost zero maintenance. We are franchisees, or we are actually giving box twin digester technology, which is proven and time tested. Practically sound, eco-friendly, maintenance-free, cost-effective, no electricity needed, minimum maintenance, self-sustainable, aesthetic appeal, no mosquitoes, no odor. You can see one of the best plants, 500 kg plant set up at Wipro in Bangalore. It is there in the front to showcase that they are nature-friendly. So 1.5 tons of carbon dioxide emissions, 1 ton biogas plant can offset this much of carbon dioxide. It's a great thing. See, this is how the pollution that you see, the air quality that you are facing in Delhi and NCR is because of stubble burning. This is an ideal solution for stubble burning, provided the government comes on a partnership basis, because the cost of these projects are minimum. For a 3-ton project, it will cost around 17 crores. And then as a thumb rule, 3.5 crores to 5 crores per ton of output, gas output, depending upon the location and the raw materials and how much of technology and automation should go into it. So this is my contact number. You can have it. Your questions welcome, and I'll be too happy to only answer your questions. WhatsApp is my preferred mode of communication, and we can do it. Thank you.
Thank you very much, sir, for a wonderful presentation. I will take up the questions now. In the meantime, can you please stop? Yeah.
Yeah, tell
Thank
me,
you,
ma'am.
sir. I will take up the question, sir. The first
Can
question
I have
is,
your video, please?
sir, we don't have access to video, sir.
Okay, right. Thank you.
Okay. I'll take up the questions now, sir. What are the challenges associated with sourcing agricultural waste for CBG plants?
Madam, any agricultural produce is seasonal. In the sense, you do a harvest and then your window is there for the next harvest. So within this period, you have to clear up the fields. This is what you see in the stubble burning also. The window is mostly around 25 to 30 days. So within this period, what you are collecting, it is a huge quantity. You will have to find a storage space for that so that you use it over a period of time by the time the next harvest comes. So if your intervals between them, each crop has got its own intervals. Say, for example, tomatoes can have a 2 months period. Uh, Rice can have a 3 month period. Cotton can have a 3 month period. Whereas sugarcane has a 10 month period. So depending upon that, you will have to have a storage area which will store this thing. So that is what is one challenge. Then seasonal items, if you are looking at the press mud or like coffee mucilage, they are all available only for 180 days or they are available for 3 4 months. So there what happens is that for the rest of the period, what do? You have set up the plan for one particular thing, then you have to make that adaptable for other inputs also. So all these challenges are manageable. So that is the entrepreneur's interest to decide on what is to be done. Now MSW is also there, where today most of the corporations are giving you segregated waste. So that is also possible. They are perennially available, but this requires challenges of dealing with the government.
Okay. Which types of agricultural wastes are best suited for CBG production, sir?
Any waste, whether it is invasive species like Juliflora, Parthenium, then controlled crops which you are doing in wastelands like Napier grass, then all your agricultural produce from commercial crops or food crops. Because as I told you, if you are taking rice, only 30% of it is edible for you. The balance is either going as fodder or you can use it for biogas. And animal waste is also part of it. If you are in a rural area, human waste can also be used as a catalyst.
Okay. What is the cost of setting up a CBG plant
I told you
using it?
larger plants, I told you 3.5 crores to 5 crores per ton of output, depending upon the level of automation, your land pricing, and input materials and the automation levels that you require. Whereas smaller types, if you are looking at, I have shown you an independent system which is with HDPE. This is a fit and forget system. These things will cost between 2 lakhs to 10 lakhs. So these are all very ideal. Normally you can take an ROI of at least 3 to 4 years. And these are, see, instead of discarding your waste, you are making money out of it. And the community kitchens are all one of the best suited items. Now, let us suppose a village has got about 300 to 400 houses. Then their excretia, all the waste they generate in the kitchen and the farm waste can all be brought together and centralized in one place. And this can be used for community kitchen. So the gas will be available. You can give 10 outlets or 20 outlets depending upon the people. And each one can come and cook and go. So these are all possibilities which we can work.
Okay. Are there government subsidies or incentives?
Yes,
for
there are subsidies. The highest subsidy is 10 crores for a 12 plan, and this is based on the output. The state governments also give, highest being in Uttar Pradesh, where they give around 75 lakhs per ton of output.
Okay.
TEDA is the agent that works out in Tamilnadu. Similarly, there are agencies in each state which are monitoring this and offering the subsidies. In fact, for the output of fertilizers, the subsidy is 1,500 per ton. But there is no clarity on how to approach, whom to approach, how they will give, because we are generating it and we are going to use it in our own farms. then what the clarity is not yet come. We are discussing that. We are also not clear on that, but we are clear on one point, that there is a subsidy of 1,500 per ton, which itself is self-sustainable for a project of this size.
Okay. What is the carbon footprint of CBG production from agricultural waste compared to traditional fuels?
The traditional fuels carbon footprints are already clear and you know about it. In this, you are only negating it, because what you would otherwise burn or mulch. See, as I told you, mulching will is 20 times more dangerous than more carbon dioxide generating, because it's generating methane. So it is 20 times more, 30 times more harmful than burning it. So we are avoiding the burning, we are avoiding the mulching, and using it profitably to replace fossil fuels. So I gave you the statistics, how much tons of carbon dioxide is replaced by a plant in my
Okay.
presentation.
Okay. What policies and regulations in India support the development of CBG from agricultural waste?
All the programs that the government is doing is based on any of these things, any biomethanation project or the renewable energy project has got a subsidy component, and this one is also coming under the MNRE. As I told you, for a 1 ton, it's based on tons, but the maximum is 10 crores, limited to 10 crores for 12-ton project. And it depends upon 1 ton also is there to on pro rata basis nearly. And I told you the output also, for every ton, you get around 40 kg of LPG, and 20% of that is a fertilizer. So fertilizer also, I told you, it is 1,500 rupees per ton is the subsidy.
Okay. Who are the major customers of CBG and how is it distributed, sir?
See, the distribution network is through the oil manufacturing companies and GAIL. So if there is a pipeline nearer to you, you can directly discharge it into it, which will save a lot of cost on in terms of filling, because that itself a 210 bar, if you have to fill, you have to use a compressing machine, which is running on a 180 or 200 HP motor. So that's a big savings. Of course, you will need it, but then this need not go to that extremes. You can directly put it into the system, because the cylinders are the costliest things, handling them and transporting them. I told you 1 ton of gas is the maximum that you can transport in a 10-ton truck. So you can see the cost effectiveness, the cost bleeding in that.
Okay. What is the market potential for CPG in
Madam,
India
we are
and
importing around
globally?
40 million tons of this thing. So whatever you produce, it is all sold. We are saving on imports. Simple as that. Even today, we are importing. Even if all the plants that are now coming, Tata, Ambani, Adani, Reliance, Praja, everybody comes also, still our gas will be required, because we are going to concentrate only on the local things, because our plants are about, let's say, a maximum of 12 tons, which how many trucks you can calculate. If they run, that is more than enough.
Okay. Are there any successful example of CPG plants using
Yeah,
agricultural
what I
waste?
have, see, all these agricultural plants can handle this thing. Only the preparation of the raw material will change. So as I told you, the plant which I showed you, the video link, I think I have given there 100 TPD, that is working on coffee muesli.
Okay. What are the lessons learned from existing CPG projects using agricultural waste?
See, this is subsidy driven. Okay. So most of the plants, I think around, if you go to SATAT scheme, you will know the number of units running. These are all bleeding because and not profitably running at this point of time. Most of them is because of the cost of raw material and the control that they do not have on the system. And some of them are based on what you call seasonal items like press mud. So what happens is your interest works 24/7 into 365 days. But if you look at the systems that are raw material availability is only for 180 days or 3 months, 4 months, these are all what affects this. And also the moment you go and tie up for these waste materials, which is otherwise not used, demand for that increases and they start bargaining. So I can tell you an example where we worked with a plant where the starting price of press mud was around 80 rupees per ton. Then they wanted 200. Today, I think it is 400 and people are now forward booking for 550 rupees per ton. So this is the reason why I am suggesting wastelands have to be converted into controlled agriculture like Napier grass, where we can have control on the raw material and also 24/7, 365 days availability. And 1 ton of this wastelands with normal rainfall can give you around 120 to 160 tons per year.
Okay. Now, what are the core services offered by your company, sir?
We are a consultancy and EPC company. So from start to finish, we can handle it. We can handhold it for 1 year also to operate it also. We can showcase the successfully running plants so that they have a feel of it. But these things will happen only after we enter into a letter of LOI or MOU and money comes in as advance, which can be adjusted in their project. Because see, there are too much of interest in this and we have non-serious players coming in. So we wanted to limit this, and so we are charging 5 lakh rupees for our starting services to show them, to give them a brief of the DPR, and then also take them and show a company which is successfully running on Napier grass. So that is okay.
What are the long-term sustainability prospects of using agricultural waste for CPG production, sir?
Agricultural waste is perennially available. As I told you, this is only the window that is important and the storing that we have to do. See, if you are going into a sugarcane producing area, that's a large areas are available. So sugarcane trash is available. Sugarcane companies waste is available. So this is a question of how best we meet with the people and how best we can harness this waste. It's a combination. The mill owners should be willing to work with us. See, because there is a line that we have to draw between need and greed. So today, I will give you an example of how a briquetting plant came to its doom. When they started it, the lumbering sawmills asked them to take it away, and they gave us amount of 200 rupees to carry it away. Otherwise, their production won't happen. Today, they are saving it, they are adding water to it and asking a bargain of 2,000 to 3,000 rupees per ton. So briquettes are sold for 7 rupees 50 paise per kg or 9 rupees. So there is a viability factor. Then the other one is based on calorific values, nobody is giving you money. So coal you can import, it has got about 6,000 kilocalories. Whereas briquettes with 4,000 kilocalories, are we realizing pro rata amount? It's a question. So many things government has to step in. They are also doing it in a great way, but entrepreneurs and factories will have to join hands on a win-win situation to see that we are reducing the carbon footprints and making best use of the waste available. And mainly wastelands. We are today, because of shortage of labor, because of shortage of funds, these wastelands are available in plenty. In fact, the High Court has brought big strictures where they are asking to eradicate these invasive species like Juliflora. As I told you, this can be used as wood, and also the smaller parts can be converted into biomethanation raw materials, both of which are valuable as a resource. But how are we using it? It's what you can see it for yourself.
Okay. Thank you very much, sir. We have now completed the round of questions. On behalf of agricultureinformation.com, we'd like to thank Mr. Divakar for the talk and for answering the questions. This meeting will now be closed.
Hope I have given enough information on this, and more information is always available. You can route it through agricultureinformation.com or directly contact me. Thank you all.
Thank you very much, sir.